All right, so in this the second video for week 2 in sprint 2, what I'm really going to focus on is describing how to generate a list of learning objectives from some type of professionally developed lesson that you found. So remember, in your project, you've already defined the main subject, gone down one level in the subject, and gone down another level in the main focus. So hopefully you're at a slightly well-scoped area of a curriculum. And in my case, my subject might be computer science or math. The sub-subject might be binary math, and then a main focus, one level down is like how to count in binary or something, that's even smaller. The point is that we're trying to get to a small enough kernel of knowledge, small enough lesson that we can do it in a 15-minute interactive experience. So whatever your lesson is, just Google it, look for YouTube videos, try to find teaching websites with recommended lessons. In my case, I found CS Unplugged. And this is a teaching program that aims to teach computer science topics without computers. So it's more engaging, it's more interactive. It tries to remove all the overhead of trying to deal with a computer and all the technical complexity that comes along with it, and maybe the finances and all this other stuff. And let's just approach computer science topics in a fun and engaging way for young children. And so one of the topics here was binary numbers. And in it here, there's tons of activities and lessons. And I was just going through here and just watching it. And I clicked here and I found a video of the teacher explaining bits to their students and how to use it to count and represent numbers. And so I just watched this. It's like a 10-minute teaching video and how she's explaining bits to maybe a middle school class. Then later on, you see that she's having the volunteer students hold up these signs that each represent a bit or a power of 2 that's growing up. And then it's a fun way to teach it. So I was able to watch this and get the gist or the lesson, the size of the lesson for binary counting. I was like, okay, this is just it's not too overwhelming. I can break it down into a series of learning objectives. And if you get maybe 10 to 20 learning objectives, about 20, I think, would be scoped about right. Because each of these statements, these are the statements that became my tutorial. And they helped me explain, okay, I have to explain this topic before this topic before this topic. And it made me think about how to demonstrate this material to the students. And it did help me to write out the tutorial because it's like Eggy Creature. I should probably put a link up to this too. But if you watch the walkthrough of Espresso,
so this video is going to serve as the current state of Espresso, Oculus Quest app, which is the binary.
I'm trying to see if at a certain point. All right, so the user gets introduced to the world through. I'm just going to mute my own self, so I don't talk over my own self. But there's this character Eggy with this text box. And you can't proceed in the experience until you listen to him and read his directions. In this case, you have to give him a high five. So the reason for that is I want the user to look around and just be cognizant, be aware of, whoa, I'm in this new space and it's all crazy. Let me understand that I can move around the space. Let me understand my hands can interact with stuff. So even just this first step of the tutorial, Okay, teach the user that they're in this virtual space. Teach the user that they can walk through the space. Teach the user that they can touch stuff with their hands. So just that one text box on Eggy taught the user 3 things. Now this one says, all right, let's paint with your hands. So not only are they showing that you can use your hands to change the environment, but with user testing with young students, they just would go crazy in this new, vibrant, imaginary world, and we just lose their attention. They're just lost. They're just running through the space. So we basically hold them there. Just go crazy, paint everywhere. This crazy abstract paintings. Actually, this is the painting app I pulled from IT 201 and just put it in this program. So I repurposed a feature I thought would work really well in something else. But the point is that you're stuck in crazy abstract paint mode. Like, just go crazy and get it all out of your system, and especially with the little kids, they just go nuts. And then after a few minutes, they get bored. Like, I need them to just get bored of the space, because then they'll pay attention. Then they'll read what Eggy has to say. Okay, give me a high five. Great, I'm training them. Now I'm teaching about this lever on the left. I said, okay, I unlocked this lever. I changed it from red to green. I want you to pull it. And now I'm teaching them that this is the interactive. This is the main interactive that they're going to use. And not only is this their main interactive with their hands, but it shows you things. It shows you that when you pull the lever this way, the bit moves into the 1 or on. If you move the lever this way, the bit moves to 0 or off. And then I showed that they interacted and changed the level with that micro interaction. By pulling that lever and changing that bit from 0 to 1, the walls came down. More of the level was revealed. Now there's even more visual candy all over the place. They just that all this had to be hidden at first because it's just too overwhelming. But now I think they're ready to see the whole level, and I show it to them. And I show them, hey, don't pay attention to all this other stuff. Just come to this one station. Come to this main task station. And I want to show you how to use it, because this task station is the beginning and the ending of each task. And the level is broken down into tasks. And you can't go to the next task until you successfully complete the current task you're on. And so it's very important for them to understand these ideas on how to use the experience successfully, how to have a successful user experience. And then I show them how that task station was giving them their task, and how Eggy then moves on to the next station to say, this is the next one that you go to. You move in a clockwise fashion. You move over to the number station. Let me talk about how to use the number station. And while I'm doing this and teaching them how to use the app, I'm also teaching them about binary math. So I disperse in the learning objectives with how to use the app. So you don't just learn how to use the app and then how to learn learning. You could do that too, but I mixed the 2 lessons together in this whole beginning introductory tutorial session. And then everything is really clamped down. Like, I'm forcing them, you have to do just this one lever. You can't get this task wrong. It's one red sphere. In each station, you can only do a 1 at the number station. You can only do a sphere at the sphere station. You can only do a red at the color station. There's no way they can fail. Actually, one of our subjects out of about 16 for this trial did actually fail this first task, and I don't remember. I think they found some type of bug where they kind of just crashed the experience, and that's how they ended up failing. But I used the first task in the level as a tutorial task. Like, you cannot fail it. You just follow me, do this. There's only one thing to do. I'll wait till you do it. Okay, great. Let's move to the next thing. Do this. There's only one thing. Do that. It's very clamped down. So I think I'm going to assign this video too, because I'm talking this whole way through it. So anything I just missed there will be covered by that video too. So I'll post that up. So now you saw that I built this experience with these learning objectives in mind, and I based it off this CS Unplugged. Like I found some material. And if you're going past 20, 30, 40, 50 learning statements, objectives, it's going to be too big, and now you got to scope down to something smaller. So now you can look at the learning objectives you've stated already, and maybe around 20 of them, maybe like, here's I can scope I can change my main focus and make it an even smaller lesson. It'll be fine for you to do that as you change as you figure this out during this phase of production. So as I watched the teacher, I saw how she taught the kids, and I started writing down the learning objectives, like a little nugget of knowledge. Explain that a bit is like a light switch. That means that it can be in one of two states, on or off. Once they get that idea, then I can explain that there are many ways to keep track of numbers, and like the decimal system that we're used to, and this is the binary system that we're being taught, and there's more besides that. And we can explain why humans prefer the decimal system, because they've evolved with 10 fingers and 10 toes, and we've learned counting on our fingers and toes more than likely. And that computers prefer binary system. They prefer to understand stuff, or they can only understand stuff in an on or off state due to them having the electrical nature. So once the students understand that, then we can explain that bits can be strung together to represent power or bases, much like decimal places. So in the decimal accounting system, our first position is for ones, our next position is for tens, our next position is for hundreds, next is for thousands. And that bits places use powers of 2, while decimals use powers of 10. But we still have these positions from right to left. So then we can explain that we read a sequence of bits from right to left, just like decimals. So once they all understand that, we can explain that the rightmost place is going to be 2 to the 0. Much like in decimal, it's 10 to the 0. So the first place in decimal counting is our ones place, and go from 0 to 9. And that's actually 10 to the 0. And in the binary system, that first spot is 2 to the 0. So in the binary, where the bit can only be on or off or 0 or 1, this can only be 2 to the 0, which is 1, and it can be on for 1, or it can be off, meaning it doesn't count, it's 0. So then you can explain that the next place over is 2 to the 1. Much like in decimal, it's 10 to the 1. It's the tens place. So in that section, you still have 0 to 9, but they represent tens. So times 10 instead of times 1. Here it's 2 to the 1. So that place can represent either a 2 or a 0. And then the next is 2 to the 2, which is 4 to the 0, and so on. And then you add them up. So if the ones place is on, there's a 1. If the twos place is on, it's a 2. And then if the fourth place is on, or the power of 2 to the 2 is on, it's a 4. If we have 1, 1, 1, it's really 4 plus 2 plus 1, or 7. If it's 1, 0, 1, that's really 4 plus 0 plus 1, or 5. Much like in decimal format, 101 would be 100 plus 0 tens plus 1 ones, or 101. So once the students get that, we can explain that you can have as long of a sequence of bits as necessary to express whatever number you're trying to express. Just like in decimals, you just keep adding place after place after place to express whatever the number is. And once we get that, you can explain that you can use a sequence of bits to represent other information besides numbers if you create a coding system. So in my binary counting, we were representing a see different types of a list of numbers and a list of shapes. If you notice the shapes, there's only 2 levers or 4 possible types of shapes that we could represent, and so we only had 4 shapes. Here we go. 2 levers, you can only have 0, 0, 0, 1, 1, 0, or 1, 1. Each of those can represent a unique shape instead of a number. And then to really drive it home, let's now have a series of 3 bits, which is even harder than 2 bits. So we have 8 colors we can represent. So we make everything a little bit harder at each stage to see if they got it. But if we make the steps small enough, these are small enough steps to learn. And yes, there's many steps, but small steps are good. And we can make sure that everyone learns the step and move on to the next one, that we have just the right size of learning chunks of objectives that come together and make a lesson. Binary counting. So I had a few more steps after this, but you get the idea. This is how I broke down. This is actually my bullet list for my learning objectives. That would go here. All right. So aim for about a list of 20. Explain this, explain that. About a sentence long. Sometimes you might need a compound sentence. I wouldn't really aim for 2 sentences, but like if you can explain an idea in a sentence in either a simple or a compound sentence, you know that that's about a good sized learning objective. And that's basically going to be the basics of your tutorial, besides teaching them how to use your app. So you have to kind of teach them the basic learning principles and then how to use the app at the same time. All right.